Okay, so we've got to talk about this new map, right?
Right.
Astronomers just released like the most amazing infrared map of our Milky Way, like ever.
Yeah.
And it's incredible.
It's really cool. It's a game changer for sure. We're talking about seeing things we couldn't see before.
I know. And it just hit me. I remember you mentioning you have your own telescope, right?
I do, yeah.
Imagine what we're about to like dive into, right? This is a whole other level, like way beyond what we could see before
Absolutely.
in terms of our galaxy.
I mean, most telescopes, even the really powerful ones, they kind of hit a wall when they try to see through all the dust and gas in the Milky Way. But this map, this infrared map, it just cuts right through it all.
It's like someone just like turned on the lights.
Yeah.
So tell me, what is it about this infrared thing? What makes it so special for seeing?
Well, infrared light, it has these, longer wavelengths than the light we see, like visible light. And that means it can like sneak past all those dense clouds of gas and dust way easier. It's like imagine having X-ray vision, but for space, right?
Oh, okay.
We're peeking right into the Milky Way's, all its hidden nooks and crannies.
That makes so much more sense. So we're seeing through the dust, but what are we actually seeing? Like what's out there?
So this map, it comes from this telescope down in Chile. It's called VISTA.
Okay.
It stands for Visible and Infrared Survey Telescope for Astronomy. And it has this amazing camera on it. It's called VIRCAM, which stands for Vista Infrared Camera.
Wow, they really like their acronyms down there.
You really do, right?
Yeah.
But the cool part is, these two, the telescope and the camera, they work together, can you believe it, for over a decade, just capturing images.
A decade. That's commitment right there.
Absolutely.
Talk about dedication.
Yeah.
So what did they find? Like what kind of objects are we talking about here?
Well, get this. This map, it can actually see newborn stars.
What?
Yeah. These stars, they're still wrapped up like in the dusty clouds where they're born. And usually you can't see those in visible light, those stellar nurseries. But with infrared, boom, we're getting a glimpse into like the very beginning of a star's life.
Whoa, like baby pictures of stars?
Exactly.
It's amazing. And this map, it covers such a huge area, right?
Huge. Okay, picture this. 8,600 full moons.
What?
All stitched together.
No.
That's how big this map is. It's actually 10 times bigger than any other infrared survey of the Milky Way we've ever had.
10 times.
10 times.
That's insane. With all that extra detail, we must be finding things we never even knew existed.
Oh, absolutely.
Like we've been looking at this blurry picture of the Milky Way for who knows how long, and now we finally have the high-definition version.
Yeah.
So what else are we seeing with this new clarity? Like, what's out there?
We're getting this amazing look at these things called globular clusters.
Oh, yeah.
They're these...
They're like the granddaddies, right?
Exactly.
Granddaddies of all the star clusters.
Yeah, these tightly packed groups of stars that are like time capsules from the Milky Way's early days.
So they tell us about the Milky Way's past.
Exactly. Because they're so old, studying them, it's like we're looking back like billions of years to this time when the Milky Way was still forming. And this map, it's giving us like the best picture we've ever had of like how they're spread out, what they're made of.
Right.
And that's going to help us figure out how galaxies, how they grow and change over time.
That's amazing.
And get this, because infrared lets us see this faint heat, right?
Right.
We can find these objects that regular telescopes would just totally miss. And we're uncovering some really weird stuff.
Okay, like what? Give me an example.
Brown dwarfs.
Oh, right.
Do you know about brown dwarfs?
The in-betweeners. Like they can't decide.
Exactly. They're like too big to be planets, but they're not big enough to be stars.
Yeah. I always thought those were so interesting.
They're so cool, right. And we used to think they were kind of rare.
Oh, really?
Yeah, but this map, it's saying, hold on, there might be way more of these things than we thought.
Huh. So that changes how we think about like how stars form and all that.
It totally changes things. It's like rewriting the textbooks almost.
Wow. So we've got baby stars, ancient star cities, and now a whole bunch of these like cosmic teenagers who can't decide what they want to be.
I like that. Cosmic teenagers.
Right. And it's not just a map, right? It's like a 3D model of the entire galaxy.
You got it. You got it. It's not just a flat picture anymore. We can see the Milky Way, like in 3D, and understand how all the stars are moving around in it.
Hold on. How is that even possible? It's like you're telling me this map is also a time machine or something.
Well, you see, it's all because of these special stars called Cepheid variables.
Cepheid variables.
Yeah, and they kind of like pulsate.
Okay.
Like they blink, basically. And how fast they blink tells us exactly how bright they actually are.
Yeah.
So by watching how their brightness changes,
Right.
astronomers can figure out exactly how far away they are from Earth.
So they're like cosmic mile markers.
Yes, perfect way to put it.
That is so cool.
And by tracking these mile markers, and a whole bunch of other stars too,
Oh.
astronomers, they built this whole 3D model.
Oh, wow.
It shows us the Milky Way's spiral arms, that big bulge in the middle,
Right.
even how the whole thing rotates.
Wow, that's incredible. So we're not just seeing what the Milky Way looks like, we're seeing how it moves, how it changes over time. But you mentioned something else earlier, something about hypervelocity stars.
Oh, yeah.
It sounds kind of intense. Hypervelocity stars.
Yeah.
They just sound, I don't know, kind of scary.
Yeah, a little bit, right?
Well, what even are they?
So, just like the name says, these stars, they're moving crazy fast.
Okay.
Like, so fast, they can actually break free from the Milky Way.
Break free? Like escape the entire galaxy?
Escape the galaxy, that's right.
How's that even possible? It's like what, something shot them out like a cannon or something?
You know, that's actually a pretty good way to think about it.
Really?
So we think most of these hypervelocity stars, they started out in like a binary system.
Okay, two stars orbiting each other.
Exactly. But then they got too close.
Too close to what?
To the supermassive black hole at the center of our galaxy.
Hold on, back up a second.
Yeah.
Our galaxy, the Milky Way, it has a supermassive black hole.
Oh, yeah.
I thought those were like in other galaxies far, far away.
Nope, it's there right in the heart of the Milky Way.
Wow.
And its gravity, it's so strong, it can literally rip a star system apart.
Why?
If they get too close, yeah.
What happened?
One star, it gets pulled in, gone, devoured by the black hole.
Eaten up.
And the other one, it gets flung out like at an insane speed. Boom, hypervelocity star.
So this map, it's helping us find these crazy fast stars, and that tells us something about the black hole.
Exactly. It's like by tracking these runaway stars, we can learn about the black hole's power, how it affects the entire galaxy.
This map is amazing. It's like a window into all these crazy things happening out there.
Right.
But I mean, it must have taken forever to make.
Oh, yeah. It was a huge effort, like over a decade of work.
Wow.
Hundreds of astronomers.
Right.
Yeah, they had these two big surveys,
Okay.
the VISTA variables and the Via Lactea survey.
Try saying that 5 times fast.
I know, right?
What is that? V something? V something?
VVV, yeah, that's what they call it.
Catchy.
And then its partner in crime, the VVV Extended Survey, or VVX.
It's VVV and VVVX. Sounds like some secret code stuff.
Right.
So what now? They made this incredible map. What are they going to do with it?
This is just the beginning. It's like we've got this treasure map,
Yeah.
and we've only found a few X's so far.
So there's more to discover.
Oh, tons more. They've already written, like, over 300 scientific papers based on this map.
What?
Yeah. And astronomers, they're going to be studying this data for decades, probably. Uncovering new things about the Milky Way, how it's built, its history, what's going to happen to it, everything.
That's incredible. And what's really exciting is this is just with the tech we have now, right?
Right. Imagine what we'll find with even better telescopes and tools.
Oh, are there new tools coming?
Oh, yeah. There's one called Foremost. It's a spectrograph.
The spectrograph, okay.
It's going to go on VISTA,
Okay.
and it can collect light from thousands of stars all at once.
All at once. Wow. What will that tell us?
We can learn about what they're made of, their temperature, how they're moving, everything. And then there's moons. That's another spectrograph, but it's for the Very Large Telescope.
Okay, the Very Large Telescope. That sounds pretty large.
Major big, yeah.
So instead of just seeing these objects, we'll be able to, like, analyze them.
Exactly. It's like going from a simple sketch to this super high-definition 3D model. We'll see everything.
That's mind-blowing.
It's pretty amazing, right? When you think about it, we've come a long way from just looking through basic telescopes.
I know. It's kind of humbling.
You really is.
Knowing there's so much more out there, just waiting to be discovered.
It makes you just want to, grab a telescope, go outside, and just look up at the night sky.
Totally.
Yeah.
It makes you wonder what else is out there.
Exactly.
What other mysteries are hiding in the Milky Way?
And who knows, maybe this map, it'll inspire someone listening right now
Yeah.
to become an astronomer, ask those big questions, and, make the next big discovery.
Wouldn't that be something?
That would be amazing.
Oh, I can't wait to see what we find next.
Me too. The future of astronomy is definitely looking bright.
I like it. All right, well, that's about all the time we have for today's deep dive.
Yeah.
From baby stars to runaway stars
Yeah.
and even a supermassive black hole, this new map of the Milky Way, it's definitely got it all.
It's definitely a game changer.
It is. Thanks so much for breaking it all down for us.
Oh, it was my pleasure. Really enjoyed it.
And for everyone listening, until next time, keep looking up.